Welcome back, everyone. This week we're going to talk about scales and unit conversions. So when you use your GPS to find a restaurant for the first time, you're often presented with a smaller version of the road. You can see landmarks and signs and upcoming turns and things like this. And even some GPS systems have speed limit signs. What you're seeing on your phone is just a scaled down version of the local area. It's just a map of what's around you, scaled down to fit your phone. Often in science and math, we want to take things that are much larger than what we can see and hold in our hands and scale them down to smaller versions that are easier to deal with. This allows us to then model behavior of large objects using a small model. One way to solve problems about scale models is to use proportions. So we have a toy model of a car that has a scale of 1 to 30. So what this means is that for every 1 unit of length in the toy model, the car has 30 times that amount. If the model is 8 inches long, how long is the actual car? If the model is 8 inches, what would be the length of the car? To solve this proportion, we can just cross multiply. And we see that the car length is equal to 8 times 30, or 240 inches. Try another example here. A model of the Space Shuttle Challenger has a scale of 1 to 64. The actual shuttle was 122 feet in length. The model is then how many feet long? To solve this, we can cross multiply and then divide. And we find the model but here, rather than writing the decimal answer in feet, write in a number of feet with leftover inches, like 5 feet, 8 inches. So rather than solve this in terms of feet, let's solve the problem in terms of inches. The actual shuttle is 122 feet. There are 12 inches in every foot, which means the actual shuttle is 1,464 inches. So now we can set up the proportion again, but this time using the number of inches. And just like before, we'll find that x is equal to 1464 divided by 64. .875 inches. Well, there's 12 inches in 1 foot, so this is 1 foot. 10.875 inches, or about 1 foot and 11 inches. The wingspan of the model is 15 inches, so what's the wingspan of the Challenger in feet? To find this, again, we can use the same proportion. However, now we have the model wingspan, 15 inches. To find the Challenger wingspan in inches, we cross multiply and we find 15 times 64, which is 960. To find the number of feet, we then divide 960 by 12. So this is 80 feet. Scales also help when we're dealing with distances on a map. Here you have just an atlas map of the city of New Orleans and the surrounding area. Notice the scale up here on the top. It tells you that 1 inch represents 4.5 miles, or it gives you the scale. And so we can use this to solve problems about the map. So assume that the distance on the map from Kenner, Louisiana to Chalmette, Louisiana is 3.2 inches. How many miles apart are the two towns? Using our scale, we know that 1 inch is equal to 4.5 miles. And so if 1 inch is equal to 4.5 miles. Then 3.2 inches is how many miles? To solve this, we can cross multiply, and we find the number of miles, 4.5 times 3.2, 14.4 miles. If we wanted to know how many inches apart the two towns are, the scale on the map, we can set up a proportion using the scale on the map. We know that if we have 3 inches or 3.2 inches on the map, how many inches in real life? And so again, we cross multiply, and we find that 3.2 times 285,100 912,320 inches. So sometimes, rather than shrinking an object down and using a scale model, sometimes we just want to express values in different units so that people can understand. For example, if you went to Europe and told someone you were 6 feet tall, they may not know what you mean because they use centimeters or meters in Europe. If they told you they were 150 centimeters tall, you might not know what that means. You would have to convert between the two units to use them. So the method of doing unit conversions is the same for all types of conversions. So we're going to start with the easiest type of conversion, and one you're familiar with, which is time. And then we'll work our way into other types of conversions. So you should already know that there are 60 minutes in an hour and 60 seconds in 1 minute. So how many seconds are in 1 hour? If we have 1 hour, we want to know how many seconds there are in 1 hour. To do that, we need to multiply and divide by these numbers that we know above, which in general are called conversion factors. What this means is that we know there are 60 minutes in 1 hour. And so if we convert from hours to minutes, we're going to multiply times this conversion factor. 1 times 60 is 60. And here, hours divided by hours, when we divide units, just like when you divide numbers, when you divide units by itself, it just divides away to 1, and those units go away. We're going to do the same thing to convert from minutes to seconds. We know there are 60 seconds in 1 minute, and here, minutes divided by minutes, these will cancel out. So 1 times 60 times 60 is 3,600. So there are 3,600 seconds in 1 hour. This process of converting units is how we're going to solve all of the problems for the rest of this section. We're just going to use different conversion factors. So how many seconds are in 1 day? Well, we know in 1 day, let's first convert to hours. There are 24 hours in 1 day. In 1 hour, there's 60 minutes. And there's 60 seconds in 1 minute. And when we multiply all of these, notice our units for time leave us with seconds. And 24 times 60 times 60 equals 86,400 seconds in one day. So how many seconds are in 1 year? Well, we know there are this many seconds in 1 day, so we can use this as a conversion factor. 1 year, and just for the sake of the example, there are 365 days in 1 year. And there are 86,400 seconds in 1 day. And this comes from our previous example. So if we multiply, notice here the units cancel out. 365 times 86,400. 536,000 seconds. Let's try another one. So now let's try this example. How much time is 1 million seconds? So what we're going to do is we're just going to convert this to the most convenient unit. 1 million seconds. There are 60 seconds in 1 minute. So 1 million seconds. Here again, the units cancel out, but now we're making bigger numbers into smaller units. So the number is going to go down. And when we do that, we'll divide. 1 million divided by 60. And that gives 16,666.67 minutes. So let's convert this to hours. There's 60 minutes in 1 hour. When we divide by 60, here again the units cancel out. And so this is 277.77 hours. It's a relatively convenient unit, but let's go one more. There are 24 hours in 1 day. If we divide them by 24, we find that 1 million seconds is equal to 11.57 days. So about a week and a half. So that was 1 million seconds. Just as another example, let's determine how long or how much time is 1 billion seconds. And again, we're just going to convert this to convenient units. This is just an example to show you how unit conversions work with simple units like time before we do something a little more complex. So how much time is in 1 billion seconds? Well, 1 billion and we can convert everything down as far as we had gone before, because we know 1 billion seconds, 1 minute. There are 60 minutes in 1 hour. Notice that you know which way the units go because you always want it to be on the opposite side of the one you're converting from. If we're converting from seconds, we want seconds to be on the bottom when we write our unit conversion. There are 24 hours in 1 day. And we can just add one more. There are 365 days in 1 year. So with our units, seconds, minutes, hours, and days, and we're going to be left with a number of years. So how many years is 1 billion seconds? To find that, we're going to take 1 billion, 1 with 9 zeros, and divide by 60 times 60 times 24 times 365. And we find that 1 billion seconds is about 31.71 years. So these are just examples to show you how unit conversions work. What we're going to talk about next is how to take this same process and use it to change other types of units, not just time. To do that, we need to have conversion factors. So here are some of the conversion factors that we're going to use on each of the problems as we're going through. Length, weight, liquid volume, time. And the important ones I want you to recognize here are the conversions between systems. And these will pop up in each of the examples from here until the end of this video. But I wanted you to have it all in one place as a reference. So let's say we want to convert 138 ounces to pounds. From our conversion factors, there are 16 ounces in 1 pound. So we have 138 ounces. And we want to convert that to pounds. To do that, we want ounces on the bottom so that they'll cancel out, and pounds on the top. If we look at our unit conversion, there are 16 ounces in 1 pound. And so we're going to divide 138 divided by 16, and that'll give us the number of pounds, which is 8.625 pounds. The process only involves multiplication and division, and it's the same as all of the time examples we did. We're just using different conversion factors, ones you're probably less familiar with. So a small car has a gas tank that can hold up to 12.4 gallons. How many liters of gas can that tank hold? If you took that car to Europe, you would measure your gas in liters, not in gallons. So how many liters would you have to have? So 12.4 gallons. We want to convert gallons to liters. Liters is a capital L. If we look at our unit conversions, there are 3.79 liters in 1 gallon. If we multiply 12.4 times 3.79, we'll just call this 47 liters. Finally, I want to show you how to perform some of these calculations in Excel. And so I'm going to pull that up just here in just a second. Assume we know the actual lengths of different vehicles, and we want to turn them into a model with a scale of 1 to 16. We know the true length of these models in feet, and so we want to determine the model length in feet and inches. So if we know the true length, we know the true length of these objects, we want to scale it down to 1/16 of its size. And so I'm going to open this table in Excel and show you how to solve this problem in Excel, along with a few other small tricks in Excel. So here we have our data typed into Excel. In order to find the model length in feet and the model length in inches, we need to use the scale that was given to us in the problem. It's 1/16. So if the boat is 17 feet long, the model length equals the true length of the boat. And so we can click this cell here, or you can just type in B2. So the true length of the boat. To convert to the model size, we want to divide by 16, 1/16 of the actual size. We can do the same thing for the car, equals, we can click here, and we want to divide that by 16. You can type in the same for the last 3 cells, or in Excel, you can click and drag by just highlighting the corner of this box, just pulling this box down. And so we find the model length of all of these different objects, and this is the model length in feet. To then convert the model length to inches, there are 12 inches in every foot, and so to convert we multiply by 12, equals We can then click on this cell again. We want to take that number times, the multiplication symbol is above the 8 on your keyboard, so C2 times 12. And then again, rather than type it in, we can just scroll down. And now we've filled in our table. Please contact me if you have any questions about these assignments.